Hello, students. Had some questions out of section 7.4. So we'll start it off here. Okay, let's see. There we go. And let me make sure, just give me a weird warning. Make sure my screen is still sharing. Am I sharing? Okay, looks like I am, at least from my side. So, all right. So the question was first over here, 1/4%, and it says convert each of these to a decimal. So right over here, I mean, you had convert decimals to percents. And again, I think this is where probably a lot of students get into some issues, shall we say. So like here for this one with 2/7, if you have 2/7%, you could absolutely write 2/7 as a decimal and then realize that you have a percentage, right? So 2,85714 repeating, and then say, but I need this. This is just the fraction part, and I need it written because it wasn't this. It was this percent. So it is this per 100. So if you want to think of it, this percent, 2/7%, this is 2/7. 2/7% is 2/7 per 100. It means I'm dividing by 100. And so you would have that as kind of moving the decimal two places, dividing, if you will, by 100. So moving everything place value wise. And there you go. So the same thing, I think, again, when students do problems, if you're trying to do it quickly, kind of in your head, you just slow down. 1/4. We know what that is, right? So if you say, aha, I'm done, then you're missing the fact that this symbol is written there. It doesn't say convert 1/4 to a decimal. It says convert 1/4% to a decimal. So with what I showed up here, we should be able to kind of expand that to handle the 1/4%. Every percent problem has the same thing, every one of them. Look at this, 125%. If I said 125%, somebody said write that percent as a decimal, and you said, aha, 125, you'd be completely wrong because percents are not exactly the same thing as decimals. You can't just erase them. If they were exactly the same, we wouldn't even use the symbol, right? It'd be something completely different. Okay, so question 4, let's see here. And then next question up was question 26. Okay, Brandy received 10% raise last year. Her salary is now this. What was her salary last year? Okay, so this is just like the ones that are on the activity sheet. So let me throw in a little white space here. So let's do not a 10%, let's do a 20% raise, right? Somebody did amazing, right? So you got a 20% raise to get to your new salary. So here's what we started at, and there's your new. So if you're thinking about it, this is a 20% raise. That means you got everything you started with, which was 100%, plus you got an extra 20% on top of it, which means your new salary, new, is 120% of the starting amount. And this is where those percent problems come into play, because this is exactly a percent problem. New is 120% of the starting value. And so if you know her new salary is 60,000, you could put that in for new. And what was her salary last year? That's the starting value. That's the value a year ago. This also kind of links back to what we do with geometric sequences. If you know how you went forward with the geometric sequence, could you go backwards? So instead of multiplying by 1.2 repeatedly, maybe you divide by 1.2 to get back to it. Okay. What you don't want to do, and I'll tell you, this is the do not do this. But I know even if I make this video, people are still going to be like, yeah, but it's so much quicker and easier. Well, if you'd like to get the answer wrong, the quickest and easiest way is just to write down anything. Like write down 7. Just write that down. You know it's wrong, but it's so quick. So instead, here's what students do tend to think of, because they're like, I know 10%, my teacher told me to multiply and then add. So they would multiply and then subtract, and that would go backwards. But it's very, very different, because now you're taking 10% of the new amount, whereas what we said is we had a 10% raise on the starting amount. And those are different values. So if you take 10%, again, this is do not do this, but your students are going to see it too in the future. 10% of 60,000, that is 6,000. And then what people do is they'll subtract it. 6,000 minus, take that away from here, and you get 54,000. And they're like, got it. Well, check yourself, right? Why not check yourself? Take this amount, 54,000, and you're doing it the long way anyway, so there's nothing I can do to talk you out of it. You're going to do it this way. Multiply by the 10%, and you get 5,400, and then add that on. And guess what? You got 59,400. So you're supposed to get 60,000. And so that is unfortunately a fail. Look at the percentage that you started with, turn it into the factor you need to multiply by, and you won't have these issues. You won't. Okay. If I know that I got a 20% raise, that's 120% that I multiply by, 1.2. If I'm going the other direction, I don't subtract, I just divide, because that's how I get backwards. That's it. That's it. Tie it all together. Let's see here. Math Connections 14 was the next question. Let's take a look over there. Math Connections 14. So I actually did a whole video on this one. So I don't know if I'm gonna. Yeah, I did a whole video on this one, so I'll just refer you to the other video. I don't want to do it again. If you tried that video and have an issue with it still, let me know. Then we can try we can try something different. Dan claims the sales tax going from 5 to 6% is only increasing by 1 percentage point. Stan says the sales tax is going up by around 20%. Yeah. Math Connection 16. Once I added the two different taxes. I'm not sure what's going on there, but let's take a look. Let's see here. So I'm going to come up here. I'm going to throw on a little bit of white space over on this side. Okay. So sales tax is going from 5% to 6%. So if you were going to pay $100 for an item, then if you were just finding the sales tax, 5% tax would be $5. In the new system, $100 item, 0.06, you get $6. Okay. So that means it went up by $1 on a $100 purchase, which would be going up by 1 percentage point, right? From 5% to 6%. Okay. So Dan looks like Dan's got it. Dan totally gets it. Stan says the sales tax went up by 20%. Well, let's see here. Here's what we started with. We paid $5 in tax. Here's what we end with, which is $6 in tax. So if I take the 6 divided by 5, I put that into a calculator. I don't need a calculator here because it's 1/5, which I know is 20%. So this becomes a 1.20, which is 120% of the amount. That means we pay the 5% plus we pay an extra 20%, or you can say this is 20% more. So we are now paying 20% more tax than we were before. So that is completely correct, Stan. And Dan says, but we're only paying 1 percentage point more. That is correct. But 1 percentage point out of the 5 percentage point that you started with is 20%. When you do that math, the percentages cancel. 1/5 is 0.2 and 0.2 is 20%. So yes, I love it. Who is correct? I love it when they phrase it that way. That should tip you off a little bit, like, who is correct? They're both correct. They're both 100% correct. And I threw another percentage in there just because. All right, there we go. 16 and 24. Let's see here. Is it that page? Oh, too far. Back page. 24. Noelle read that women used to make 75 cents for every dollar that men made. She says that means men were paid 25% more than women. Is she correct? So this is a brilliant way of kind of pushing students to start to do mental math. And we'll have to kind of see what you think and why you think that. So what do you think? If you think this is true, okay, so woman makes 75 cents. The man makes $1. So I'll call that 100 cents. Okay, so there we go. And so men make 25% more increase. So if we gave women a 25% raise, they would be up making the same amount as a man. Is that true? And let's take a look. So if you are following a more traditional path, which I will just go ahead and say is typical American schools, you may not have had a good solid understanding of percentages to begin with because we tend to glaze over them in our system right now. They tend to be blended in, especially if you're using integrated math programs. So instead of covering them well once, what you'll do in American schools is you'll cover it poorly 5 times. And someone might even say something ridiculous, like they call this a spiral approach. And so what you have to do is kind of think of this like it's a tube. They love the tube analogy. And so you think of this like it's a 3-dimensional tube. And so each column on the side of this tube would represent like percentages. So here's percentages. And so then what you say, and it's horrible pedagogy, but this is what they say. They say, well, we're going to cover it here. We're going to touch on it here. And then we're going to wrap around the tube until we come back around in the next grade level. And then we'll touch it again. You see how we touched it again? Whee! And then we'll do it again. And they say, but look at all these times we've integrated percentages. Look, see, so they've had it so many times, and they look at each one of these and say every one of these is an interaction with that. The problem is that every time you do something poorly, you can do it a lot more. It does not firm up the foundation. You have to understand the foundation. What are percentages? We have a percent. It is a ratio. We can think of it as a part then, because it's also a fraction. It's a part of something. And whenever you have a part of something, you need to know what is my whole amount. So if you are thinking, look, there's a difference of 25 cents, that's a 25% change. Well, maybe it is, and maybe it's not. You have to know what is the whole object, right? So if we were looking at men and saying 25% of the man's piece would be 25 cents, and therefore, look, if you go this direction, you get back down to women, it's exactly 25 cents less. So, aha, that would be it. That is reasonable thinking, but the way you say that is very different. That would mean that women are what we are looking at as the future part, and man is what we started with. So we would say women make 25% less than men. That's how we would phrase it. Okay, that statement would be correct based on what you see here with these numbers. I'm not going to get into the numbers here. Again, if you get into education, you really don't see any of this at all. You will not. Nope, because there is a unionized pay scale and it does not matter what your gender is. And that's how we do it. It's, you look over here, how many years of experience, that's how much you get paid. That's it, which is good and bad. It's really good if you're okay with that, And it's bad if you're a great teacher because you start realizing you get paid exactly the same amount as someone who is not as great. All they have to have is years of experience. Okay, 25% less than men. Does that mean that men make 25% more? And hopefully you've seen already in this term, in this section especially, that is not the case. A 25% drop cannot be overcome by a 25% increase, because we started with 25% of 100, and now we don't have 100. We have 75. So in order to get back up to 100, I have to do something different. I cannot do the same thing again. So that's why, thank you, Noelle, for reading that, assuming that the dollar amounts are actually correct, then her interpretation of that ratio is incorrect. Because what you're really doing, you're saying, what would I do? I'd start with 75 cents. I'd multiply by something, and that would get me to 100. So if you bring that over, P is equal to 100 over 75. 100 over 75 is what? 4/3. So 1 1/3. You want to turn that into a percentage? That's one. Well, let's do this way. 1.3 repeating. So I get the decimal form, which becomes 133.3 repeating percent, which is 33.3 repeating percent more than. So you see, it all depends on this whole. Where are you starting with? If you're starting with the women's salary, you're trying to give it a boost to get up to the men's salary, then you have to look and say it's 25 cents out of the 75 cents. That's my base. My base is the woman's salary. If I'm going the other direction, I'm starting with the man's salary and working my way backwards, then you would say, well, I want to take a percentage of the men's salary and kind of remove it to get down to this. Okay. So there you go. There's the pieces there. Be careful with this. This is so easy to make a mistake with. That's why I put those extra videos together about percent increase and decrease. And that's why the activity page as well, we'll do more with that. The activity page is really, really important. And let me, let's see here. I'll have to go back in. I'm not sure if I posted that yet. Let's see. Oops, got all my stuff all over the screen. Where would I go? Oh, here. So 7179. Yeah, I don't have the. Well, let's put it up there. It's 7.4. I'll put the activity, the percent activity. Percent activity will be right here. All right. So we'll stop sharing on that. I will post that. That'll be up for everyone, the blank one. But when you look at it with your percent activity, let's see here. And it looks like it's a Word document, so I'll save it as a PDF. But the idea behind that percent activity is that you actually go through and say, well, wait a minute, what does it look like when I have to go forwards and backwards? And I know students were struggling with some of those even in class. They're saying, how do I go backwards? And again, it's because of the way that you, unfortunately, were taught, that we're trying to overcome a little bit, because the way that you were taught to do some of these percentages was not to think about what is your whole object. It was just to start doing stuff. And unfortunately, that's where we run into a lot of problems. So let me save this and we'll take a look at some of these activities from the percent worksheet. Let's take a look. Okay, percent activity worksheet is up. And let's take a look and see what it looks like here. Okay. So yeah, again, this is, I don't know all of your math histories. And again, even if I knew some of it, every teacher is a little bit different when they cover things. So what I want you to do is kind of take a look. When you do, if the sales tax is 8%, what is your total cost? It's not asking you for how much the sales tax is. If I wanted just a sales tax, yes, I would take 8% of the $80 and get the sales tax. Okay, which is what, $6.40, something like that. Okay. Okay, perfect. Awesome. That's how I do sales tax. That's not what it's asking me to do. And again, if you were in this traditional system, you would take 640 and then you come down and say, okay, so 80 plus $6.40, and you get 86.40. And you'd say, okay, that's how I get my total. I tried to prompt you, can you do this in one step? And I hope that you're able to kind of look and say, wait a minute, I do have to pay 100% of the price of the item. And then I have to pay an extra 8% of the price of the item. So yeah, you could do 108% times $80, which would be 1.08 times $80. And you would get to $86.40 right away. And the reason why that is so important, because you are multiplying the starting value to get to the ending value. If you're trying to go backwards, you know this is my ending amount, $80 total, and I don't know the starting amount. Well, just think, if I multiplied to go forwards, I'd better divide to go backwards. And that's all you have to do, because your starting, or maybe your original, multiplied by 1.08 has to get you $80. So how do I go backwards? You would divide to get original by itself. 80 divided by 1.08. And that's how you can get there. You can grab your calculator, take a look. But what you will never get correct is if you just take the $6.40 and then subtract it from 80. If you subtract that and you get what, 73.60, it won't work. It'll be impossible for that to work, because you're trying to take 8% of a smaller amount and raise it up to that bigger amount. It's not going to work. So we have to think about these as multiplicative. If you can change your mindset to think of sales tax, interest on loans, anything like this, that if you change your mindset and you say all of these are multiplication, they are not addition problems, you're actually going to be able to get a lot more of them correct, and it's probably going to feel a whole lot easier. So that's the big piece as we go through this, and we'll go through more of this. But again, if you purchase an item at 40% below retail, that means the retail price is up here, I am paying less than that. So I paid 40% less. Awesome. What percent of that retail price are you paying then? Well, you would have had to pay 100%, but you bought it for less than that. So you're not paying 100%, you're paying 60%. You're paying less than 100%. That's the idea for these. And then at the end of the day, when you look at it, now how do I get from that from that wholesale cost? How do I get from there? What do I multiply by to get to bring that up? That's where we get to use what we were just doing here, solving. Use your calculator as well. Here we go. 80. Let's see here. Yeah, same thing here, right? $50 bill. You get an 18% tip, and it includes that. Basically, there's no tax at this restaurant. That's fine. How much did the food cost? Well, the food cost is like your original amount. The food plus the tip gives you the $50 bill. How much was the tip for the waiter? I can't tell you how many people want so badly to take 18% of 50 to find how much I tipped the waiter. Well, your bill wasn't $50, right? It was something else. And you added 18% onto that something else, and then you got $50 at the end of the day. And lastly, to try to push the idea that these are multiplicative. I know they say more or less, they do, but I want you to start saying more or less. I can think of that in many different ways. The way I want to think of it as multiplication. Okay, so 37% more than something. Got it. That's 137% of what Angelina made, because you made all of what Angelina made, Brad, and then you made more. Okay. All right. So that about wraps it for this one. Hope that's helpful. But again, hit me back if you got another one, or bring it to class. All right, off you go.